Hi everyone, in this lesson we're going to be using derivatives to find equations. And we start off with some vocabulary. Of course we have the derivative, the slope of the tangent line at a point. Usually we represent that by f prime of x or y prime of x. And the equation of a tangent line to a point, we have point slope form here, and we're just replacing what we usually write as m with f prime of x, which is the slope of the tangent line at a point, our derivative. The steps to use the derivative to find the equation of a tangent line are: we're going to find the derivative, that's the equation of the tangent, input the value of x to find the slope of the tangent at that value of x, and then we'll use our slope and our point in point slope form to write the equation. So for number one, the first thing we're going to do is find the derivative of y. And there's our derivative. Step two, we're going to input the value that was given for x to find the slope at that value. So in this case, y prime of 3, our slope is 17. All right, we're almost done already. We have our point and we have our slope. Step 3, we're going to use our slope and our point to write the equation. Now we'll just fill it in. And now we have our equation. So we're really done, but as you know, I always like to put it in slope-intercept form. So I'm just going to clean this up a little bit, distribute the 17 to start, and then add 25 to both sides. And so our final answer here is y equals 17x minus 26, or you could have just left it in point slope form. Either of those are okay. Now that first page should have been review. Now we're moving into something just a little bit new. You should remember it though from your algebra days. The slope of a perpendicular line. The slope of any perpendicular line to a line with slope m is the negative reciprocal of that. So for example, if we have this equation of the line and we want to know what slope would be perpendicular to the slope of that line. Well, the slope of this line is just 2. So the perpendicular slope to that line would be negative 1/2. All right, that's vocabulary review from Algebra 2. That's this guy. Now, normal line, that's not probably something you've heard in the past. The normal line to a curve at a point is the line through that point that's perpendicular to the tangent. So when we say normal line, we mean perpendicular. Normal equals perpendicular. And the equation of a normal line then is just going to be our typical point slope form, but we're replacing slope with our slope of a perpendicular line, which would be the negative reciprocal of our slope. So same steps as we did on the first page. We're going to find the derivative, the equation of the tangent, input the value of x to find the slope of the line at that value, and then we're just going to remember now that we're talking about the normal line, and that means we're going to be using the perpendicular slope. All right, so step 1 here, we're going to find the derivative. We have a quotient, so I'm going to be using the quotient rule. Now I'll just go ahead and fill that in. We have g f prime minus f g prime all over g squared. Just write that a little neater now. And when we simplify that, we're going to get 2 over x plus 1 squared. All right, so we've completed step 1. Now we're going to input the given value of x to find the slope of the tangent line at that point. When we simplify that, we get 2 over 25. If our derivative is 2 over 25, if our slope is 2 over 25, our perpendicular slope is going to be negative 25 over 2. Now we can do step 3 using point slope form. And now we can just go ahead and fill that in. And so we've completed our mission here. We found the equation of the normal line, so that answer is perfectly acceptable. But as you know, I like slope-intercept form, so I'm going to keep going. In my final step, I'll add 3/5 to both sides. And so now I have my equation in slope-intercept form. Either of those will work. All right, on the next page, we're going to learn to use technology to find the equations of the tangent and normal lines at a given point. So it says find the equation of the tangent line to the following curve at the point indicated. So first we're going to do it by hand, and then we'll compare our result to what we get using the calculator. Step 1, we're going to find the derivative. I'm just going to rewrite this to be in exponential form. So I'm going to rewrite it as x to the 1/2 power. And now I'll go ahead and do step 1 and find the derivative. Then I'm going to take my value of x, which is 1, and input that into my derivative. When I do that, I get 1 over 2 root 1, which is just going to give me 1/2. All right, so I have my slope, I have my point right here. Now I can use point slope form, and I'll just fill that in. And now, since I know my calculator is going to give me the equation in slope-intercept form, I'm going to simplify this to slope-intercept form. All right, so that's what I get for my equation of the tangent line at that point in slope-intercept form. Now I'm going to follow the steps to use the calculator to confirm my result. I'm going to graph the function. I'm going to hit draw, select tangent, and at that point I'll be able to see the equation of the line at the bottom of my calculator screen. So let's do that. All right, first thing we're going to do is go to y equals, and we're going to enter in our function. Now we're going to go look at the graph, so zoom 6 for a standard window. All right, now we're going to draw our tangent line. So we're going to go to draw, second program. It's highlighted in red on my screen right now. And we're going to select number 5 for tangent, because we're drawing the tangent. And it's asking us what value of x we want to draw the line, so we're going to type 1 and hit enter. And it's drawing our tangent line at 1, and you can see our equation right here at the bottom of the screen. It's y equals about 1/2 x plus about 1/2. Now we're going to do the same thing to find the equation of the normal line to the following curve. So it says first find the equation of the tangent line to the curve at the point. All right, so we're going to go back to our calculator, go to y equals, we'll clear this out, and we're going to enter our new function x squared. And we're going to find the equation at the value of 3. So we're going to go to graph, we're going to go to draw, so second program, we're going to choose tangent, and we're choosing the value of x equals 3. So hit 3 and hit enter. All right, so that is the line tangent to the curve, and we have it right here at the bottom of the screen, y equals 6x minus 9. So let's write that down. Now we're going to use the slope from this equation to write the slope for the normal line. Normal line means it's perpendicular. Here our slope is equal to 6. So the perpendicular slope is going to be the negative reciprocal of 6. So it's going to be -1/6. And now we can use that information to write in point slope form the equation of the normal line. So let's write point slope form first. We know our x1 value is 3 and our y1 value is 9. And the slope is -1/6. So we're just going to fill that in. And so that's our equation in point slope form. I'm going to convert it now to slope intercept form. right, so either equation is an acceptable answer. That's all I have for this lesson, everyone. Thanks for watching. Have a great day.